Welcome to another episode from Spiral Physics Education. Before we look at energy transfer diagrams, to remind you a few things that we've covered before to help you get the most out of these energy transfer diagrams. So, to start off with, things that will help you here is having an understanding of energy stores and energy transfers, examples of energy stores and transfers, the principle of conservation of energy, and also that when energy is transferred between stores, that not only is it, some of it anyway, transferred into useful stores or transfers, but some is also transferred to the surroundings in the form of thermal energy, and we call that dissipated or wasted energy. So in this lesson we're going to be looking at a general introduction to the shape of these energy transfer diagrams, and there's no better way of doing that than looking at a few basic examples for you to get started with. Why use them? Well, we use them basically because there's a nice visual aid for people to see what's happening in a system when there's energy stores and transfers involved. Rather than just looking at lots of words, we can see visually what's happening between all the different types of energy stores and transfers. So let's get straight into it by having a look at a very common example that's used in exams actually, and that is a simple one of a battery powering a light bulb. So what we normally do is start off with the energy that's stored in the battery, and because there are chemicals in the battery, there's chemical energy stored. Then for the transfers we use arrows, so the transfer of energy from the battery is going to be done electrically around that closed circuit. And when it gets to the light bulb, that light bulb will get hot and it will get very warm, and its thermal energy store will increase. And because it's warmer than the surroundings, it will transfer some of its thermal energy to the surroundings. And what we say there for a good exam answer would be that thermal energy is dissipated to the surroundings. Not only that, but because it gets warm and it glows, there'll be radiation energy transfer in the form of light, and that's the useful thing for light bulbs. Let's have a look at another example. Let's consider a wound up toy from the point at which it's been wound up. So we draw a box for the starting energy store and its elastic potential energy, and we draw an arrow to represent the transfer, and because that will involve forces, there'll be a mechanical transfer. So there'll be transfer done mechanically, and that will increase the kinetic energy store of the toy. There'll be some friction involved, there always is, and what that will do, it will transfer thermal energy to the surroundings, so there'll be thermal energy dissipated to the surroundings, so it will be wasted. And also they're noisy things, so there'll be radiation energy transfer in the form of sound. So let's have a look at a third example. In this third example, let's consider a person running. So people run on food, food's a chemical, so we all people have chemical energy storing inside us. We transfer all of our work via our muscles, so that's a mechanical transfer, and if we're trying to run, that mechanical transfer will increase our kinetic energy store. We'll also get warmer, so our thermal energy store will increase. Maybe we'll start sweating as well. And what that will do, because we are warmer than the surroundings, we will transfer some thermal energy to the surroundings. So thermal energy will be dissipated to the surroundings, i.e. wasted. And it's usually a noisy affair when you're running, so some energy will be transferred to the surroundings in the form of radiation, in the form of sound. So I hope you found that useful, and please do check out other videos on the channel from Spiral Education, and hope to see you next time.